Before we talk about polynomials, let's see the relationship between the dividend and the divisor. So if I take 3 as a whole number and I want to divide 3 by any divisor, what are the divisors that I can take? So I can divide 3 with 1 and we will get 3, 1 3s are 3 and the remainder becomes 0. We can divide it by 2. So we have 2 1s are 2 and the remainder is 1. And in all these cases, we are subtracting here. And then we can have 3 divided by 3, the same number. And then again, we get the remainder as 0. Can I divide 3 by 4? Yes, we can. But in this case, we need to put another 0 because 4 is greater than 3. So we need to add this 0. And then we need to add the point here. So the quotient becomes a decimal number. So to get whole numbers as our quotient, we can divide it by 1, 2, and the number itself 3, but not the number greater than 3. And can I divide it by 0? What do you think so? Can we divide 3 by 0? It is as if I am doing 3 upon 0. And can we have 0 in the denominator? No, that is undefined. Right? And so this case is not possible. This case becomes undefined as well. Okay, so we can't put 0 in the divisor. It's not possible because that's undefined. So what is the relationship between the dividend and the divisor? Divisor can either be less than or equal to the dividend for division, okay? Now let's see the relationship between the divisor and the remainder. And it says the remainder is always less than the divisor. Okay, so let's see, this is the divisor and this is the remainder that we are talking about. Now here I am dividing 12, 13, 14, 15, 16, 17 with 6. All of them are divided by 6. And you get different remainders. Because 12 is a multiple of 6, you get a remainder of 0. 13, 14, 15, 16, 17 are not multiples of 6. And so you get the remainder 1, 2, 3, 4, 5. And now let's talk about 18 being divided by 6. And since 18 is a multiple of 6, 6 3s are 18, you will get 0 as a remainder. So look at all the remainders that you are getting. You get 0, 1, 2, 3, 4, 5. Again, you can get 0. Then if you are dividing 19 by 6, you will get 1 and 2 and 3 and 4 and 5. And again, you will get 0. So you can see that the remainders are always going to be less than 6 because 6 is our divisor. So remainder is always less than the divisor. That's the relationship between divisors and remainders. Now let's move forward and look at the relationship between all 4 of them, the dividend, divisor, quotient, and the remainder. So if you are dividing whole numbers by whole numbers, you will get this relationship that dividend is equal to divisor into quotient plus the remainder. And you can see in all the cases that we have looked till now, you can see 6 2s are 12 plus 0 gives you 12. 6 2s are 12 plus 1, 13 will give you 13. 6 2s are 12 plus 2 gives you the dividend 14. If you look here, 3 1s are 3 plus 0 gives you the dividend 3. 2 1s are 2 plus 1 gives you the dividend 3. And you can see in all these cases that this is the relationship between all 4 of them. Now, let us talk about polynomials, and then what is the relationship between dividend and the divisor when we talk about polynomials. Now I have taken polynomial, this is a linear polynomial, this is a these 2 are quadratic polynomials, and these 3 are cubic polynomials. And when we look at polynomials, we look at the degree of the polynomials. So if it's a linear polynomial, you can divide it with another linear polynomial because their degrees are equal. Now, a quadratic polynomial can be divided either by a linear polynomial, which is less than the degree of a quadratic polynomial, or by itself. So any polynomial of degree 2, then you can divide them. If you look at the cubic polynomials, cubic polynomial can be divided by linear polynomial, quadratic, or cubic. So one polynomial with a degree of 1, 2, or 3, but not greater than 3. So you can't divide a quadratic polynomial with a cubic polynomial because cubic polynomial is a degree 3, which is greater than this degree 2. Okay, so that's the relationship between dividend and divisor. When we talk about polynomials, we look at their degrees, and then the degree of the divisor can be either less or equal to the degree of the dividend. And now let's divide this polynomial, which is a quadratic polynomial, with a linear polynomial. So let's divide this. So we have x into what will give you 3x squared. So x into 3x will give you 3x squared. Now 3x also multiplies with the 1. So 3x into 1 gives you plus 3x. Now since we need to subtract this, I will change the sign of this both terms. So positive 3 becomes negative, and here positive 3 also becomes negative, and these two will cancel out. We have positive x, 1x, minus 3x gives you negative 2x, and then negative 1 comes down. Now x, what should I multiply with x to get minus 2x? So I can multiply minus 2 with x. So x into minus 2 gives me minus 2x. Sorry. And minus 2 also multiplies with positive 1. So minus 2 into positive 1 gives me positive 2. Sorry, negative 2. And I need to change the sign of this. So this becomes positive, negative becomes positive, again negative becomes positive. Now these two, negative and positive, cancels out. Here I have minus 1 plus 2, which will give me positive 1. And this is my remainder. Now look at the relationship between the remainder and the divisor here. So if I look at the remainder, what's the degree of this remainder? There is x variable with a degree of 0 here, right? And you can see the divisor had a degree of 1. And so the degree of remainder is less than the degree of divisor. The degree of the remainder is less than the degree of the divisor. Okay, now let's see if the relationship between all four of them, divisor, dividend, quotient, and remainder, is satisfied when we talk about polynomials. So we have dividend is equal to divisor into quotient plus remainder. In this case, our divisor is x plus 1. Our quotient is 3x minus 2. So I have placed them here. And the remainder is a constant 1. And now let us solve this. Okay, and I'm going to use this pen. Okay, so if I have to solve a binomial with a binomial, I take x, and x multiplies with the whole bracket, 3x minus 2, and then we have plus 1, which also multiplies with the whole bracket, 3x minus 2. Okay, and putting this into a bigger bracket, we have plus 1 outside. So let's multiply this. We get 3x squared minus 2x plus 3x minus 2, and then there is plus 1. So what do we get now? These two are like terms. We can get it and make it, we can add it and make it plus 1x. So we have 3x squared plus 1x, and then minus 2 plus 1 becomes minus 1. And you can see this is exactly the dividend that was there in the quotient in the problem here. So it is 3x squared plus 1x minus 1, which is what you get here. It is exactly as you get, as it is exactly, and so you can see it is exactly the dividend which was given in the example here. 3x squared plus 1x minus 1 is what you get when you multiply divisor and the quotient and add the remainder. So this works for polynomials as well. So in general, if you have two polynomials p of x and g of x, where we will take p of x as our dividend and g of x as our divisor, are two polynomials such that the degree of p of x is greater than or equal to the degree of g of x. So the degrees are either g of x is less or they are equal, and g of x cannot be 0 because then it's undefined. I cannot have 0 in the divisor. Then we get two more polynomials and we will call them q of x and r of x, which is the quotient and the remainder, such that multiplying g of x and q of x and adding r of x will give us p of x. That means multiplying the divisor and the quotient and then adding the remainder will give us the dividend. And where the degree of r of x, that means the degree of the remainder, is less than the degree of the divisor. So the degree of r of x is less than the degree of g of x, or the remainder could be 0.